All right. Series circuits, 23.11. Today we're going to talk about how to draw these circuits and how to solve these circuits. So our big equation for today is going to be the Russian equation, VER, P equals IR. And the other one that we're going to use that I didn't put up here is PIV, the Poisson-ID equation. Now remember that current is I, it's measured in amps. Resistance is R, measured in ohms. And the voltage or potential difference, same thing, is V, and it's measured in volts. So we're going to use VER and we're going to use PIV. Okay. Now for a series circuit, all of them are on the same wire. So a nice simple series circuit has all the circuits on a single loop. The rules for series is voltage is added, current is constant, and resistance is added. So those are the rules for series. And today we're only going to cover series. Tomorrow we're going to cover parallel. And Friday, we're going to cover series and parallel combined together, which gets really complicated. So even though this seems very easy, and I'm going to end up doing a lot of work for something that you could probably do in your head, I want you to practice this because when we get to Friday, you won't be able to do it in your head anymore. And all the stuff that you use here will make more sense on Friday. So all that extra work that you're doing will pay off. Now this is only true for series circuits. So if all the resistors are added in a single wire or on a single loop, that is when these rules are true. This is not for every single circuit. This is series. Most of our circuits are going to have a battery and resistors. They're going to leave out this output. We won't really deal with that too much. All right, so I'm going to get right into a practice for you guys because that's the best way to do this. Just explaining what the rules are and giving you equations isn't going to work. I did create a grid to solve circuits, so that's what I'm going to teach you how to do today. Again, you probably don't need the grid for these 2 days, but it's a good practice for when we get to Friday and organizing your information. So what you want to do is make a really terrible noise named VERP. Very rude noise. And for this circuit up here, we have 3 resistors. So we need to do a column for each resistor, and then a column for the total resistances. So we have R1, R2, R3, and total. And if you want to leave the R's off and just go 1, 2, 3, that's fine. Now again, this grid is to help you organize your information. It is not a requirement, but it does help, especially when we get to the combination circuits. Anything that's voltages or potential difference is going to be measured in volts. So that row is all volts. This one's going to be all amps. This one will be all ohms. And the bottom one is power, which will be all watts. You don't need to write the units when you're using the grid. To start out with, it might help you, but I'm not expecting you to write them. Okay, so here's our setup. This is our nice little grid. I like to redraw my circuit on the paper because it helps me visualize a little bit better. I'm a visual person. So I just redraw my circuit. Now, this circuit has 2 on top and 1 on the side. It doesn't matter where you put the resistors.
Thank you.
You could put them all on the top, all on the bottom, all on the side, spread them all out. It doesn't matter. This one's 1, 2, 3. They're labeled 1, 2, 3 up there. It doesn't matter what order you label them in. The grid will work. So if you call them A, B, and C, that would be fine. If you did it 1, 2, 3 this way instead of 1, 2, 3 this way, it will be fine. So don't worry about that. Now from this picture, we have the first resistor is 40 ohms. So under resistance and the first resistor, I put 40. And the second one's 100. And the third one is 60. The other number that we have is 300 volts. It's at the battery. You can pretend that the battery is kind of like the total. So anything total is like stuff at the back. And that is 300 volts. So those are our givens. Now using these rules and using these equations, we can solve for all the missing spots on this grid. So we're going to start with the rules. We have resistances, and in series, since they're all in series, we can add up the resistances to get our total resistance, or it's also known as the equivalent resistance. So if it ever asks you for equivalent resistance, you just know that's total. So let's add all these resistance up. Our total, because they're in series, is just R1 plus R2 plus R3. And we can write that in our grid. Easy peasy, right? You don't need a grid for that. Okay, the next step is to use, we've got 2 things filled out our boxes. Whenever you have 2 numbers, you can solve for the other missing ones. We'll just work with this one here. We have V, we have R, so we can find I. So let's use VER. V total equals I total, R total. V total is 300. We're looking for I. And we have an R total, multiplied, of 200.
I was expecting it to be like right here.
There we go. So 300 over 200 giving you 1.5. I total 1 point. Again, pretty easy. Probably don't need a grid for that. Probably don't even need to write down the equation. But we're practicing good stuff. Okay, next one. Go back, figure out what's constant. So I is constant. Since I is constant and it's all in series, the I that's total will be the I for each one of these. So that means we can put 1.5 under all of these. 1.5. Now this equivalent resistance, I have to just step back for 1 second. This equivalent resistance here is like taking all these resistors and smashing them into one resistor. So if we redraw the circuit, it would look like this with one resistor. So this would be our total. So it just simplifies the circuit. So when we found all these things at the total, it just means this is what's everything on the circuit, so it would be the answers for this. But then, as we move on, we need to figure out what is the voltage on each one of these. So now we're going back and looking at this. So we started here, we smashed everything together, solved for our totals, and now we need to go back and solve for the missing stuff. So that's why we've put this constant current all the way through. Now that we have two numbers in each of the spots, we can use V equals IR to solve. So I'm just going to write the first one down and I'll do the rest of it just through the calculator. But V1 equals I1 R1, so we're going to multiply 1.5 times 40. And that should give you, what, 60? I don't trust my math anymore. I made a mistake on this one earlier. 150, 90. So use V equals IR on each one of these. Any questions? Anyone confused about any of the numbers? Okay, the last set is power. So now that we're looking for power, we're going to use P equals IV. So I want you to multiply V and I together to get power in each column. So here's an example. P1 equals I1 V1. V equals I1 is 1.5. V1 is 60. So power is equal to 90. And when we get to your combined circuits, your complex circuits, this is going to be a lot more work to get this far. And if you make a mistake, it's going to throw off, it could throw off one column, one row, or like a whole section of it. So you want to double check. Here's how to double check. You add up the powers on each resistor and make sure it equals the total power. So this is our double check. We did P equals IV for each one of these numbers. So now we're just going to add them up and make sure that it equals 450. That's your double check. If it doesn't, or if it's not very close, then you know you made a mistake and you can go back and try to figure it out. On the test, you're going to get a point for every single one of these boxes. And when I add these up, I do indeed get 450 right on the nose. Now, you won't always get it perfect, and that's because of significant figures. If you round a little bit different than you do in other places, it's going to be a little bit off, and that's okay. A little bit off is fine. If it's a significant difference, then you probably want to go back and check your numbers. But on the test, you'll be given a grid like this, and each one of these is going to be a clicker question that you input the number in, and they'll be worth a point. Each one will be worth a point. Even the ones that I give you. So I'm going to give you the resistances. They're given. You put those numbers in, and you'll get points. Hello? Sure. Becky, Dean's office. All right, so let's look at the questions here. What is the resistance of the system? So your total resistance is 200. What is the current of the system? So your total current is 1.5. What is the potential difference across each resistor? That would be 60, 150, and 90. What is the power dissipation at each resistor? 90, 225, 135. And what is the power of the system? 450. Any questions? No? Okay, I'm going to let you do one on your own. It is a clicker question. You can set it up the exact same way that we set it up here, except for it has 4 resistors instead of 3. So you need to add another column to your grid. I would recommend using the grid, but if you don't want to use the grid, I can't make you do. When you find the total current, so this number right here, that's the number that this question's looking for, but the next question is going to ask for power. So if you want to go ahead and solve the whole thing, the next question will we'll have that. We'll be the next evaluator. All right, and here we go. And I'm going to come around and help.